Good morning. Myself Ashagla Devi, Assistant Professor in Rohini College of Engineering and Technology. Today we are going to discuss about the topic working of convolutional layers. So first we are going to discuss about the working of convolutional layer. So the convolutional neural networks use parameter sharing and operate directly on image volumes. So an input image is represented as width into height into number of channels. A smaller patch called as filter or kernel or slides over the images. So at each position the filter extract the important features like edges, textures and patterns. So the output produced is called as the feature map, which is usually had reduced spatial dimension but increased depth depending upon the number of filters used. Next is convolutions mathematical view. So let us understand the convolution mathematically. Filters usually have a smaller sizes like 3 cross 3 cross 3 or 5 cross 5 cross 3. So these filters slide over the input images with a specific stride, which is the number of steps the filter moves each time. At every location, the filter performs a dot product with the corresponding part of the image. If we use the multiple filters, each filter produces one feature map, so that the number of output feature map is equal to the number of filters. Next is layers used in convolutional nets. A convolutional neural network is especially has a sequence of layers, each transform one volume into another. For example, if our input image is 32 into 32 into 3 RGB image, the network will pass through a series of layers such as convolutional layer, activation function, pooling layer, flattening, fully connected layers. So each layer plays a specific role in extracting and learning different levels of features. Next is input layer. Input layer simply receives the raw image, for example 32 cross 32 into 3 input size, and directly fed into the first convolutional layer. Its job is to pass the input image volume to the network without modification. Next is convolutional layer. The convolutional layer is a core building block of CNN. It extracts the meaningful features from learnable filters. These filters are generally small, such as 3 cross 3 or 5 cross 5, but they slide over the entire image. If we use 12 filters, for example, the output will be 32 into 32 into 12. So meaning the depth is increases to 12 features map. Next is activation layer. Once the convolution is done, we apply an activation function to introduce the non-linearity. Without non-linearity, the network cannot be learned complex patterns. So the common activation functions used are ReLU, leaky ReLU and tanh functions. So importantly, the output shape from the activation layers remains the same as the convolutional output. Next is a pooling layer. So we apply pooling to reduce the spatial dimensions. Pooling helps to reduce the computations and avoid overfitting and retain the important features. In max pooling, we'll take the maximum value in each region. In average pooling, we'll take the average. And next is flattening. After all convolution and pooling operations are complete, we need to convert the three-dimensional output into one-dimensional vector. This step is called as flattening. Flattening prepares the data so it can be fed into the fully connected layer. Next is fully connected layers. The fully connected layers performs the final classification. Every neurons in the fully connected layers is connected to every neurons in the next layer. So this part of network learns high-level combinations of features extracted by the earlier layers. So the final layer is the output layer. So it uses the activation functions like softmax for multi-class classification or the sigmoid for binary classification. The output is set of probability scores indicating which class of input image belongs to. So this is about the CNN and different layers of CNN. Thank you.